Hi everyone, in this video we will see the Wumpus problem. How can we solve that how can we prove that Wumpus is present in 1 comma 3 square with the help of propositional logic. Okay, so that only we will be seeing in that in this video of Wumpus problem. So here I have given the 4 cross 4 grid of the Wumpus problem and its states, current states it is being given. So all the tiles in that Wumpus, all the grids in that Wumpus problem, I have named it as 1 1, 2 1, 3 1 and 4 1. And also all the elements that of the Wumpus problem also I have given, like pit, breeze, stench and and where the Wumpus is present, where the actual agent is present. All these things are given. Basic informations about this problem are given here. So you know the conditions. I hope everyone knows the condition of if pit is there in the particular square, then its corresponding adjacent squares will have breeze. For example, take this. Here pit is present here and its corresponding squares are 2 1 which got breeze in it, and 3 2 here also breeze is there, and 4 1 also got breeze in it. And also here same way, here pit is here and it's all adjacent 4 squares got breeze in it. So this is one thing you have to note. And wherever the Wumpus is present, its adjacent grids will squares will have stench smell. Stench smell here represents some bad smell. So that is what it is given here. When the Wumpus is present in particular grid, its adjacent squares will have stench smell. So that is what it is given here. This is the general things about the Wumpus problem. We will start proving. We are asked to prove that Wumpus is present in the 1 comma 3 grid. With the available informations, we have to prove that Wumpus is present in the grid 1 comma 3. So with this, since the agent is present in 1 comma 1, he can perceive only its adjacent node adjacent squares information. For example, in this case, agent is present in 1 1, so he can either move to 2 1 or he can move to 1 2. Okay, so agent is currently in 1 1. So we can write the infer the rules from the current scenario of the Wumpus problem. For example, R1 I will frame. So R1 indicates that there is no stench. Since the agent is present here, he cannot sense any stench smell or breeze in it. So that we can write that we can write the equation as negation of S11, which means there is no stench smell in cell 1 comma 1, which indicates there is no chance. So here no stench smell means, and then its adjacent squares are 2 1 and 1 2. Definitely Wumpus will not be present here. If Wumpus is present in any one of the cells, then here stench smell will appear. Definitely agent might have sensed that. Since the agent does not sense anything, we can say that no Wumpus is present in 1 comma 1, which we can write as no stench in 1 comma 1, which indicates no Wumpus is present in 2 comma 1 2 1, and no Wumpus is present in 1 2 1 2. And current cell also, for safer conditions, we can take the current state also. We know that agent is present in that 1 comma 1, so we write that and no Wumpus is present in 1 1. So this we can say it as rule number 1. Then how we can infer rule 2? So we have only 3 states. One is 1 1. We have here represents agent can perceive only 3 states, either 1 1 or 2 1 or 1 2. Okay, assume that agent moves from 1 1 to 2 1. Okay, 1 1 state we have written with regard of stench smell. So assume that agent 1 moves from 1 1 to 2 1. So we can once he moves from 1 1 to 2 1, he can feel the breeze here. So that represents 2 1, there is no stench smell. He feels only the breeze. So we can say that negation of S 2 1, which indicates there is no stench smell in 2 1 grid because agent sends only breeze. So we can write it as no stench smell in 2 1, which indicates there is no Wumpus in this adjacent cell or here or here. Okay, so that only we are going to write now. So which we can write as negation of no stench smell in 2 1, which indicates no Wumpus in 1 1 and no Wumpus in 2 2 and no Wumpus in 3 1, and for safer purpose this condition also we will include no Wumpus in 2 1. So this is the second rule for this particular cell we can write. Okay, then what will be the rule 3 we can write? Rule 3, which is this one, that assume that once your agent comes here, he feels the breeze, he comes to know that any or some of the adjacent pits near this particular cell has pit in it, so it is not safer. Here adjacent pits are this one and this one, but which grid it has to move, agent does not know. So for safer purpose he will come back to the original position. Okay, so what is the starting position? This one. Again he come back. Then another possible solution he explored, and he came back thinking that it is not safe, and again he came back, and again another possible is this one. So he will move that side, and here what he senses? He senses the stench smell. Okay, then he come to know that we can write the rule 3 as there is a stench smell in 1 2, which indicates the Wumpus may be present either in here. The stench smell getting means Wumpus may be present in here or here or here. So these are its adjacent cells. So in this 3 cells somewhere Wumpus is present, that's why here it is getting stench smell. Okay, so how we can write that? Stench smell in 1 comma 2 indicates that Wumpus is either in 1 3 or we have to earlier we used and, because we will not be knowing where the Wumpus will be present, so we used and. But here any one place only Wumpus will be present, so we are using or it will be in Wumpus is present in 2 2 or Wumpus will be present in 1 1, or for safer condition, to be in safer side we will include this 1 2 also, current position also. So Wumpus is in 1 2. So these are with these 3 possible rules only we are going to infer that whether Wumpus is present in 1 3 or not, 1 comma 3 or not. So that only we are going to prove. So only these three rules can be used, or if you ask means no. So from this we can, all the known facts we can write here. For example, you can write, we know that there is no stench smell in S1, so negation of 1 1. And then what else condition we can write? There is no stench smell in 2 1. Here also no stench smell, so negation of S 1 2, that also we can write. And also we know that here the agent is safer, so here we can say no Wumpus in 1 1, so negation of Wumpus 1 1. So in this way we can write so many conditions from the available conditions. We can derive the sub conditions also. We can write the sub conditions which we consider that agent is true, which we consider that it is true. So with these conditions only we are going to prove that Wumpus is present in 1, 3. So these are the rules I have inferred from the available informations. So we will start solving the proof. So first I will take the rule 1, which is negation S11 implies negation W21 and negation W12 and negation W11. So I will take the first equation. So before solving that problem, we should be aware of this rule, which is called modus ponens rules. Modus ponens rule. So which indicates that if P implies Q, in this P is true means, given that P is true, then we can say that Q is also true. Okay, so this is the rule, we call it as modus ponens rules. Applying these rule only we are going to derive this one. Okay, we are going to prove that this resolution proof. Okay, so for that what we will take, we will take the first equation. Consider this as a P and this part as your Q. So P implies Q given that P is true. What is our P? Negation S11. Okay, we know that there is no stent smell in 11. Okay, you know that here there is no stent smell. Agent perceives no stent smell. So by default that is true. So we can say that P is true. So we will compare this given rule 1 with no stent smell in 11. So this is by default, we know that from the problem statement we know that this is true and this is your P. So here P implies Q given that P is true. We know that P is negation S1 is true. So comparing these two, what we can write, applying this rule, P implies Q, P implies Q. Given that P is true, then Q is also true. Then what is our Q? Negation W21 and negation W12 and negation W11. So this is our Q. So this is also true. So we can write by applying unit resolution rule, we can write that negation W21 comma negation W12, we can split it and write negation W11. Okay, so we can have it this equation as 1. So this is our first equation, first rule. So now we will take the second rule. So what is our second rule? So here I have written the rule number 2. Okay, so again applying same, by applying modus ponens rule, we can say that we know that negation of S21 is true. So what is negation of S21? There is no stent smell in 21. There is no stent smell in 2. That we will check with the diagram. So here this is the 21. This is we know that there is no stent smell in 21. So that is by default it is true. Okay, so since that is true, we can write as negation S21. So now this is your P. So this is your P and this whole term, considering this, it is your Q, and P implies Q given that P is true. Here you can see negation S21, negation X21, P. Both are P. Given that P is 2, we can write we can write negation W11 and negation W22 and negation W31 and negation W21. So by this we can write here. So now I will take the third rule. So here I have written the rule number 3, and by applying same rule again, by applying modus ponens rule, which is P implies Q, comma, given P is true, then Q is also true. So applying this rule, we know that there is no stencil in there is a stencil in 1, 2. That we will check with the diagram. Going back to the diagram, agent perceives that here in 1, 2 stencil is there. So that is true. So we are writing this as S12. So this is your P and this whole term is your Q. P implies Q. Given P is true, then we can write Q. Q is also true. W13 or W22 or W11 or W12. So this is our third equation. So with this equation we will compare the equation 1 and this we can write it as equation number 2. Comparing 1 and 2 we will solve this. So here also it can be by applying unit resolution rule. By applying unit resolution rule we can write these sentences separately. I will show here, which can be written as negation W22, comma, negation W31, comma, negation W21, and one more condition, negation W11. So how we have written that first condition? No, that way, by applying unit resolution rule. By applying unit resolution. So now we will apply 1 and 2 in the obtained equation. So what we got here? So 1 also I will take and write it here. What is the 1 we got here? Negation 1, 1 already is there. Negation 1, 2. Negation W12. And then negation 2, 1 already is there. Negation 1, 2 is there. Negation 1, 1 is also there. So using this equation we will evaluate this one. Okay, so from here we will take W12 negation W12 I will take. These two will get cancelled and I will be left with W13 or W22 or W11. Then again negation of W11 I will take and these two will get cancelled. I will be left with W13 or W22. Again I will compare with this equation. Negation W22, these two will get cancelled. I will be left with W13. And this proves that with this itself we can stop that. Hence Wumpus is present in W13, hence it is proved. Or else normally while solving propositional logic we will take it as negated goal 1, 3, which we will compare and we will cancel and it will take us to null. This proves that our assumption negation of Wumpus 1, 3, which means Wumpus is not in 1, 3 is false. Therefore Wumpus is in 1, 3 is true. Hence proved. Thank you.